in this video we will be looking at how to find out loops in a given flow sheet, and how can we convert that loop into a set of TS streams. So when we have a particular partition which is cyclic in nature, we need to first identify all the possible loops within the partition. Before that, there are some terminologies. However, these terminologies are for your understanding purpose. You can use the way in which you want to implement the loop, as I will show you in a few next slides. So there is something called as full string. When it is a complete string, you use both unit and stream number in it. A, S1, B, S2, C, S3. It's a full string. String, wherein only stream we talk about, S1, S2, S3 is stream string. Stream loop is the loop which have C, S3, D and S6. That becomes the loop, and stream loop is S3, S6. So you can either write only streams, or you can write combinedly stream and unit, or you will only write if S1, S2, S3 are not given, you can write 1, 2, 3, 4, 1, 2, 3, 5, whatever, like this. So first job is find out all possible loops within the diagram. So in this case there are 3 loops. You identify all the 3 loops. So these are the 3 loops, right? S3, S6, S1, S2, S3, S4 and S1, S2, S5. These are the 3 loops, and these 3 loops are converted into loop incidence matrix. That is, you write loop in these rows and all the streams in a column. And then let's say for example loop 1 has S3 and S6. So for loop 1 against S3 and S6 write 1. The remaining either you can keep blank or you can write 0. Same way loop 2 has S1, S2, S3, S4. So I'll write 1, 1, 1, 1 here. Here it will be dash. And for loop 3 it is 1, 2 and 5. Remaining is dash or 0. So that way you generate the matrix. Now how will this matrix help you? The basic principle in loop finding algorithm for tiering is that every loop whichever is present in flow diagram must be broken at least once. So you want to identify the combination of TS streams that every loop is broken at least once. Like if I give you one example, whenever there is a stream which is present in a particular loop, say for example S1 is appearing in 2 and 3. So if I say S1 is a TS stream, then loop number 2 and 3 are broken. So along with S1, if I take S6, if S1 and S6 are my one set of TS stream, what I'll get is I'll be able to say that loop 1 is broken by S6, loop 2 is broken by S1, loop 3 is broken by S1, and this is a set which is quite acceptable, quite reasonable. However, in this diagram, if you see, it's not only one combination S1 and S6. There can be more than one combination. Like in the same case, S1 S3, S2 S3, S2 S6. So this approach gives you all possible valid TS sets. However, which TS set you would like to work with depends on the your requirement. So loop finding gives you all possible TS sets, but then you have to choose which is to go with. And there is one more aspect to it, and that is the multiplicity. That is, if a particular stream is breaking loop more than once, then it goes to multiplicity. So if I say S2 and S3, so if I go back to the table S2, S3, if I take S2, S3, I say that loop 1 is broken once, loop 3 is broken once, but loop 2 is broken 2 times by S2 and S3 both. So the multiplicity of that particular set is 2. Here we will define an exclusive TS set with a multiplicity of 1. So as far as possible, we'll try to keep the multiplicity to 1, because if it is broken, if a particular loop is broken more than once, it will create more timings in solving that particular loop. So we'll discuss about this, and we'll also try to discuss this example in next 2 or 3 classes. Thank you very much.